So, the indirect damage of water hydrolysis, which is caused by, as we have seen, due to formation of chemicals, mainly the H2O2 inside the cell. So, H2O2, if it present in a DNA molecule with proteins, it will lead to molecular breakdown. And molecular breakdown, of course, when a molecule is broken, it will subsequently lead to cellular damage. Radiation hazards, just to summarize, if they are in a somatic cell, if they are in a direct, it means by direct hit of DNA or RNA, it will lead to radiation-induced malignancy in the individual. Or if it was indirect due to chemical formation, which is toxic, the H2O2, it will lead to breakdown of large molecules of proteins and DNA, and again it will lead to cellular damage. The radiation damage, which is if it occurs in a genetic cell, then again it could either be direct due to direct hit. This will lead to radiation-induced abnormality. Or if it is indirect by toxic H2O2 formation, it will lead to breakdown of large molecules. However, the effects will not be seen on the individual, but it will be seen on the offspring. The direct effect, DNA, and the indirect effect is H2O2 and then ion radicals. Again, it will affect the DNA. So the DNA and RNA, of course, which are present, basic components, of cellular components, whether they are somatic or genetic, then it will lead to cellular damage. As you can see here, this is a representation of what occurs on the chromosomal level. Chromosomes, when they are hit directly, they no longer can retain their original shape, so they either reverse the genetic code or they translocate. Either way, what is happening here actually is that the ions which are formed, the broken molecules, they will try to reunite. They will try to reunite in any way. By their reunion, they will change their basic shape, either by inversion or translocation. And either way, the gene is no more. The gene on that chromosome is not more active anymore. There are factors that affect the radiosensitivity. These are summarized in this slide. See, first and most important is the dose. The amount of radiation which is received, the higher the dose, the greater is the effect. Of course, there is a threshold. If there is a threshold, we saw that these are the deterministic effect. If there is no threshold, we describe this as the stochastic effect. So, naturally speaking, if the dose is high, the effects are high, whether on cellular level. The dose rate. Dose rate is the rate of exposure. Is the dose given, the high dose given, all at a single shot, or it is divided? See, a total dose of 5 gray can be given as 5 gray per minute. You can kill the patient actually if you give the 5 gray in a single minute, or you can fractionize it. It will be less destructive and the injured cells can recover. And this is what happens in radiotherapy. Radiotherapy, they don't give, the patient is not given the whole dose in a single setting, in a single session. It has to be subdivided so that the carcinogenic cells are killed, and at the same time the healthy cells, they are given time to reproduce and replace the killed cells. Oxygen level is important. The higher the oxygen level in irradiator cells, the greater is the damage. That is hydrogen H2O2 formation. So if you want to increase the efficiency of radiotherapy, you put it in a high barated oxygen, so that it increase the chances of killing the cells. And another important factor is the linear energy transfer, abbreviated as LET, the rate of loss of energy from a particle as it moves in its track through the matter. See, if the particle, remember the alpha, if you can go back to the previous slide, this is what we termed as the quality factor. The quality factor is high. The alpha particle, for instance, it will give, or proton, it will give its all energy in a short distance of the tissue, and this is the effect is high. In X-rays, for instance, they can affect the tissues, but they do not lose all their energy through the irradiated tissue. They might even leave out of the body, or out of the irradiated area. So linear energy transfer, the higher is the Q factor, the more is the effect. The more is energy deposited to the tissues, and the more are the effects of radiation. Now the question is, why do we, as we now understood, that we are exposed to radiation almost everywhere, any time of the day? Why don't cells die? Why don't people die from being irradiated or being exposed to radiation? Here the question is, plus these factors, is that please consider the ability of the cells to reproduce. When cells are damaged by the irradiation, they die. Just like when we injure ourselves, and of course cells are affected and damaged, so there will be reproduction of new cells. Now the cells which are irradiated and they are affected whether by direct or indirect effect of radiation, they will, as we said, they will be damaged or they will die. Okay? Either way, if there is time for the body and the body is healthy and the dose is small, the body can regenerate those lost cells. However, the regeneration process differs from one tissue to another. Like if nervous tissue is different in regeneration from mucosal tissues, for instance. Either way, when the cells are irradiated, they will reproduce and they will replace those cells which are damaged by radiation. But if the dose is very high and the time of irradiation is short, okay, then this will exceed the reparative ability of the cells to reproduce and hence replace those damaged cells. So the body cannot survive, or the tissue cannot survive. This is what happens in burns and large doses. That's why even radiotherapy, as we said just a moment ago, is that we need to fractionize the dose so that we give time for the healthy cells to regenerate and replace those cells. But if the dose is high and the damage goes beyond the reparative ability of the cells of the body to reproduce, then there will be, those effects that we discussed in the previous videos. Okay, thank you.